Let's talk about dividing radicals. When we are dividing radicals, it's similar to multiplying. You can only divide radicals that have the same root. So square roots can divide by other square roots, and cube roots can divide by other cube roots, and so on. So some simple things to remember is that you want to divide like roots, which I just talked about. We want to rationalize the denominator, so I'll show you where that comes into play. And then when you're dividing by a binomial with a radical, you have to multiply your numerator and denominator by what we call the conjugate. Examples of conjugates are, for instance, 3 plus x. The conjugate means to change the sign in the middle. So the conjugate of 3 plus x is simply 3 minus x. Another example is 2 plus 4i. The conjugate would be 2 minus 4i. For 3 plus the square root of 2, it'd be 3 minus the square root of 2. So you're just changing the sign in the middle. Negative 5 plus the square root of 3x would be negative 5 minus the square root of 3x. So we'll look at some examples of this in just a minute. First, let's look at some more simple examples. So for our first one, if we have the cube root of 12 divided by the cube root of 2, we can simply divide because they are both cube roots. So the cube root of 12 divided by the cube root of 2 would be the cube root of 6. And then when we break down 6, we only get 2 times 3, so we don't have anything that we could take out. So we just leave it as the cube root of 6. For example 2, we have the square root of 100 divided by the square root of 25. So we could say the square root of 100 divided by the square root of 25 would be the square root of 4, which comes out evenly as 2. Now you might be thinking that the square root of 100, you could also do that separately, and you can. But if you were given this problem, you could divide by the square root of 25 first. But you could do it the other way, which would be the square root of 100 would give you 10, and the square root of 25 would give you 5, and you can get 2 that way. So sometimes when we do problems, there is more than one way they can be done. For example 3, we have the cube root of 3 over 4. So when they give it to you like this and it's not separated, first step is to separate them. So we would say that's equivalent to the cube root of 3 divided by the cube root of 4. And this is where we have to rationalize the denominator, because the cube root of 4 doesn't come out evenly. We want to make it come out evenly so that we don't have a radical in the denominator. And that's what we mean when we say rationalize the denominator, like get rid of the radical that's in the denominator. Radicals in the numerator are okay. So what we want to multiply by in this case would be what number could make 4 turn into something that I could take out evenly. So if we think of 4 as 2 times 2, I would need one more 2 to be able to take this out evenly. So I'm going to multiply, I can only multiply cube roots by other cube roots, but I just need one more 2 so that down here in my denominator, it would give me the cube root of 3 2's. Write that one a little better, so that I could take out a 2 evenly and there'd be nothing left behind. So I'm going to keep going and put a 2 over here, and then we'll work on the numerator. So in math, we definitely can't just multiply the denominator. That's illegal. So we have to multiply the numerator by the same thing. And the reason why we're allowed to do that is because this is equivalent to 1. So we're still technically not changing what we were given. So then I look at my numerator. I have the cube root of 3 times the cube root of 2, which can multiply together to be the cube root of 6. So having a radical in your numerator is fine. In the denominator, not okay. So we have to rationalize the denominator and make it come out evenly. And then make sure we're simplified over here. But I can't divide 6 by 2 because 2 is not under a cube root sign. So I'm done. Let's look at example 3. The 4th root of 2/3. For the first step we do is separate that into the 4th root of 2 over the 4th root of 3. So we don't often have to deal with the 4th root, but the 4th root is very similar to the cube root. It's just that I'm going to need 4 of something to take it out evenly. So we want to multiply by what would make this 3 turn into 4 3's, and in that case I just need 3 more. So to actually write it out helps you to see that that's why you're doing this step, is to force it to come out evenly. We have to have 3 more 3's. So we'll have 4 of them, and we could take one out evenly. So it gives me the 4th root of 4 3's. So we have 4 and 1 comes out evenly. Like here we had 3 of a cube root and 1 came out evenly right there. And now we can look back at our numerator. Again, you can't just multiply by something in your denominator. So we could write that the same way. That way it doesn't look funny. And we have the 4th root of 2 times the 4th root of 3 3's. So putting all that back together would be the 4th root of 2 times, and you can even, if you don't have your calculator, you could take this in stages if it turns into a big number. But we have 3 times 3 times 3 would be 27, so we could say 2 times 27 would end up with the 4th root of 54. Now right there, you might think that you need to break down 54 and see if you can take anything out. But technically you just had it broken down and you couldn't take anything out. See, we had 3 3's and 1 2, which gave us 54. So if you didn't have 4 of something already, you're not going to have it if you break it down at this point. So that's how we know we're finished. We have the 4th root of 54 all over 3, but we've gotten our denominator all cleaned up. So let's look at 2 examples that need the conjugate. So here are the ones that need the conjugate because their denominator is a binomial that includes a radical expression. So 4 minus the square root of 3. The only way to help get rid of that is to multiply by the conjugate in your numerator and denominator, because we can't just multiply the denominator. But let's talk about the denominator for a minute first. The reason why we use the conjugate is because this forms a difference of 2 squares. And we already know that a difference of 2 squares doesn't have that middle term. The middle term will cancel out. And so it helps this radical to go away. Let me show you. So we have, if we were to FOIL this out, we get 16 for the first term. We get 4 square root 3 for the outside term. We get negative 4 square root 3 for the inside term. And we get minus the square root of 3 times the square root of 3, which is the square root of 9, for the last term. And so you can tell right there, my middle terms will cancel out, and I end up with 16 minus the square root of 9. And the square root of 9 is equal to 3. So 16 minus 3 comes out nice and even as 13. So it helps get rid of the radical. The conjugate will always do that. It turns it into a difference of squares and helps get rid of all the radicals in the denominator. In the numerator, we have to multiply by the same thing we did in the denominator because this is equivalent to 1. So up here I only have 7 times 4 plus the square root of 3. So you have to distribute the 7, and we end up with 28 plus 7 square root 3 all over 13. Now the only way you could reduce this answer is if 28 and 7 and 13 all divided by the same number, but in this case they don't, so we just leave it like that. Now let's look at this last example. We have 5 minus the square root of 2 in the denominator, so we automatically have to multiply by the conjugate. So when you see these problems, that's what you know you have to do. There's no other way to get rid of that radical. So we bring over 5 plus the square root of 2 over 5 plus the square root of 2. And in the denominator, since we know the difference of squares will help us, you just have to multiply the first terms and the last terms because the middle will automatically cancel out. So don't do that work. So we have 5 times 5 will give us 25. And the last term would be minus the square root of 4 because the square root of 2 times the square root of 2 is the square root of 4. That'll give us 25 minus 2, which is 23. And then in our numerator, this problem has a little more going on because now we have a binomial times another binomial. So that goes back to multiplying radical expressions. We're going to have to FOIL our numerator. So let's just take it first term first, 2 times 5, which would be 10. I'm going to write it down here. Outside would be 2 times the square root of 2. so 2 square root 2. Inside would be 5 times the square root of 2. So we have 5 square root 2. And last would be the square root of 4. So we can clean that up. So now I've got 10 plus 7 square root 2, and the square root of 4 would be 2. So we could say our final answer would end up being 10 plus 2 is going to be 12 plus 7 square root 2, and we already have 23 in our denominator. And again, you could check to make sure these numbers out front can't reduce, but if not, that's all you can do. So 12, 7, and 23 cannot reduce, so we leave it like that.